Hi, today we're going to new topic, volume of solid revolution. So the keyword will be solid. So before we go into the solid part, we're going to review some basic idea. So let's take a look at this diagram over here. We define the area, the shaded region, in terms of big R and small r. So we have two concentric circles to find the area of the shaded region. So we're going to use the area of the big circle, subtract the area of small circle. So we get pi big R squared minus pi small r squared. So now let's take a look at part B. Part B, we have a 3D diagram. I want to find the volume of the pipe in terms of big R, small r, and h. So now we can see that the cross section is going to be looking like this one. Okay, so the area of the cross section will be the big circle's area, subtract the area of the small circle. So we say that to find the volume is going to be the area of the cross section times the height. So the area of the cross section is going to be pi big R squared minus pi small r squared, and then times h. Okay, so this is going to be the formula driving our lesson. Now let's take a look at number 2. Rotate the shaded region about the x-axis, then find the volume of the resulting solid. So now we have the diagram, which is a triangle. Okay, it's bounded above by y equal to x plus 2, below by y equal 2, and then the interval is x equals 0 to x equal 2. So imagine that you are going to use the x-axis as the axis of revolution, and you're going to rotate the triangle, spin really, really fast. Okay, then you can see that you're basically doing circular motion, and if you do so fast, you're going to see a solid, a 3D diagram. Okay, it's kind of difficult to imagine. Okay, so I'm going to show you how it looks like on a computer program. Okay, now you can see it. All right, so I'm going to rotate y equal to x plus 2 and y equal to the two functions, the upper function, the lower function. It's bounded by x equals 0 to x equal 2, that's the x interval, around the y equals 0. Y equals 0 is the equation for the x-axis. Now I'm going to click on rotate. Okay, now you can see it. This line, this white line is y equal to x plus 2, and then this horizontal line is y equal to 2, and then you can see this triangular shape over here is rotated around the x-axis very fast. And because it spins so fast, it becomes a 3D. Alright, so now, do you see it? So now, the thickness, okay, of the solid is defined by the triangle. And then in the middle is halo, it's empty. The reason is because there are some distance between the triangular shape and the x-axis. So we are going to find the volume of this halo solid. It's irregular shape. Okay. So if you want to try this program by yourself, so you can, okay, here is the, alright, do you see the website? Alright, now we're going back to our 2D diagram. Okay, so now we're going back over here. We're going to sketch the 3D diagram on our picture over here. So we call this the axis of revolution. That is the center of revolution. Okay, y equals to 0 is the equation of the x-axis. So now we're going to rotate, and we can see that it looks like a halo, like a cone shape. All right, so now we are going to pick a point over here. I'm going to draw one cross section. So this is going to be the center of the circles. When you do rotation, it already have circles. Okay, so rotation, it gives you circular motion. So you're going to see circles as cross section. So now we're going to use this as center of the circle. So I'm going to draw. The first function you hit is going to be the small radius. So now it's going to be this long. So I'm going to get my inner circle. So now you are going to go back to the same center. You're going to draw another segment. So you're going to hit the outer function. So this is going to be the big radius. Okay, so you're going to have this much. Now I'm going to get my outer circle. So I'm going to connect this. Now I get my 3D diagram. So can you imagine that? Okay, it looked like the diagram that you see on the computer software. So we have a irregular shape. Okay, it looked like a halo cone that get chopped off. So how do we find the volume of this solid? We cannot use the regular formula that we learned in geometry. So there must be another way to find it. So we are going to use a very special way, which relates to what we learned before, the Riemann sum. So now let's take a look at this. We're going to review Riemann sum. So when we use Riemann sum to approximate the area underneath a curve, we draw many rectangles. So to find the area rectangle, we do base times height. So you have many base times height, base sub 1 times height sub 1 plus base sub 2 times height sub 2. And then when you make the number of rectangle tend to infinity, then you're going to have summation I equal to 1 to infinity, and then f of x sub I, and then times delta x. And then f of x sub I is the height of the function. Okay, the height. Okay, so delta x is the base. So after we make the number of rectangle tend to infinity, so we can replace it by integral a to b f of x dx. Okay, so height times the base times the height. So now we are going to use the same idea. So this is the solid that you see. Okay, I did not draw very well. Okay, so now if imagine that you're gonna slice this solid many times, you are going to have many small slices. So each slice will look like this. Okay, they're very thin. Imagine a slice of carrot. Okay, you slice a carrot, it will look like this. So you have a big circle and small circle, and then you have a very tight, neat little piece. So the thickness height is going to be delta x. The reason is because you have x and y. So you're going to, each height is delta x. It's going to be the difference between the consecutive x values. So now we learned that in the part A of number 1, we said that to find the area of the cross section, you're going to do pi big R squared minus pi small r squared. So to find the volume, it's going to be the area of the cross section times the height. So each little piece, you have a volume of pi r squared minus pi r squared and times h. So you use sub 1, that will be the first piece. And then you keep adding it. So pi big R sub 2 squared minus pi small r sub 2 squared parentheses h. That will be the volume of the second piece. You're going to add all the pieces volume together, and then as the number of pieces tend to infinity, then it turns into pi r sub 1 squared minus pi small r sub 1 squared delta x, and then keep going this way. And then as a number of slices tend to infinity, we're going to use the summation symbol. The sum of this function, okay, pi r squared minus pi small r squared delta x. And then you are going to replace by integral a to b pi big R squared minus pi small r squared dx. And then r is r of x. Small r is small r of x. The reason is because your radius, okay, it changed. In the beginning, you had your radius is bigger over here. As it goes this way, your radius gets smaller because it could become narrower. The pieces get smaller. So therefore, the big R and the small r, they are all a function of x. And then the a and b, we already know that it's going to be the smallest and the biggest x value. So now we're going to make it more general. So the volume of solid of revolution is going to be integral a to b pi big R squared minus pi small r squared dx. Big R is R of x, and the small r is also R of x. And the more general form of it is volume of solid of revolution is integral a to b area of cross section dx, because that is the area of the cross section. You have two concentric circles in this case. So now we're going to use the formula that we learned, and we're going to go back to question number 2 and solve it. Okay, let's take a look at question number 2. So we drew the diagram already. So we say that the formula, volume equal to integral a to b area of cross section and dx. In this case, we have the cross section that have two circles. So in this case, the area cross section is pi big R squared minus pi small r squared. So now we have to find the big R. Okay, so big R. So if you go back over here, the big R is the red one. It's a distance between this outer function and the x-axis. So therefore, big R is the distance between y equal to x plus 2 and y equals 0, which is the x-axis. So that means r equal to x plus 2 minus 0. So r equal to x plus 2. Okay, that's why we said that the r is a function of x. Okay, it changed as you go this way. The big R change. Okay. So now the small r is going to be the one in dark color. So it's between the x-axis and the line y equal to the inner function over here. So therefore we say that the small r is the distance between y equal to and y equals 0. Okay, so we always use top minus bottom to get positive. We want our radius to be positive. So therefore 2 minus 0. So therefore the r equal 2. So you may wonder how come it's a constant. If you look at the diagram over here, our inner, okay, small r is always fixed. Okay, it always fixed. So therefore r equal 2 is 2 units. Now once we found the big R and small r, we're ready. So b equal, so we're going to use a to b. So you can see that this diagram, the triangle, is rounded from x equals 0 to x equals 2. So therefore 0 to 2. In our cross section will be two concentric circles. So therefore pi r squared minus pi r squared, pi big R squared minus pi small r squared dx. I am going to type in this in our calculator. So they all have a pi in common. So I'm going to factor out a pi outside first. So I'm going to get integral 0 to 2. Now your big R is x plus 2. So parentheses x plus 2 whole thing squared minus small r squared. Now small r is 2. So 2 squared dx. So I just factor out the pi. Okay, I can rewrite it over here. That is pi, okay, 0 to 2, big R squared minus small r squared dx. Okay, that's how we got this part over here. Now next step, all I have to do is type in the calculator, then you will get answer. If you want, you can do it by hand, that's your choice. So now I'm going to have math 9, 0 to 2, and I have parentheses x plus 2 holding square minus 2 square, and then dx. Okay, I'm going to turn it back into fraction. So I got 32 over 3. So therefore it's pi times 32 over 3, which is 32 over 3 times pi. Okay, so we finished the question number 2. Now let's take a look at question number 3. Number 3, this time I'm not going to show you the 3D diagram. If you're interested, you can go online and try it. So when you try it, you do y equal to parentheses x to the half. Okay, that's how you type it in. You have to use the half exponent. So over here, the question asks you to rotate the shaded region about the horizontal line y equal to -1. So this time, you are going to rotate about the y equal -1. So now I have to draw this line because it's not there. So I want to draw the line y equal to -1. And then I am going to use this as my axis of revolution. Alright, so now I am going to draw a cross section. So I am going to pick a point over here. Okay, so I don't want to pick the point over here because they intersect over here. So it's easier you pick a point not at the end point, so you can see the small radius and the big radius. So this is going to be the center of the cross section. So I'm going to draw from up. The first line I hit is y equal to half of x. So this is going to be the small radius, the inner function, in y equal to -1. I'm going to bound the small radius. So we say that the small radius is the distance between y equal to 1/2 x and y equal to -1. So small r equal to 1/2 x minus -1. Y will cancel, so half of x minus -1. The small r will be 1/2 of x plus 1. So we found the function small r of x. So now I am going to sketch my inner circle. Okay, it's not going to be perfect. Okay, now I am going to use a different color to draw the big radius. So over here, I'm going to draw a little bit next to it. If on top of it, you may not see it. So now I'm going to use my red color. I'm going to go up, and then this time we're going to hit the y equals square root x. So the big R is the distance between the outer function y equals square root x, and always with the axis revolution. So therefore big R equal to y equals square root x, subtract y equal to -1, always top minus bottom to get positive radius. So square root x minus -1. So big R equal to square root x plus 1. Okay, so I found my big radius. Now I'm going to sketch the outer circle. So one more time, it's not perfect. Okay, so now I am going to connect this, because from -1 to 0, 1 unit, from -1 to -2, another unit. Okay, so they have to be symmetrical. That's how my 3D diagram look like. Okay, so you're going to see it. It still look like a cup. Okay, so it's not perfect. Okay, so if you want to see the perfect diagram, you can go to the software. Use the website that I show you, and then you can type in the equation. So now we're ready to calculate the area of the cross section. So we say that the area of the cross section depends on the shape of the cross section. So over here you get small circle and big circle. So the area of cross section is still going to be pi big R squared minus pi small r squared. Okay, so now we are going to do volume equal to integral a to b area of cross section, okay, dx, and integral a to b pi r squared minus pi small r squared dx. So at this moment you will notice that when you have a solid that results from a rotation, it always has something to do with the circle. Okay, so that's why our area cross section are going to use pi big R squared minus pi small r squared. It always circular motion. So that's why your area cross section always has something to do with the circle. So now A to B, that will be the smallest x value and the biggest x value. Let's go back over here. This is your regular, okay? This was the original, okay? Say the region. Okay, it began with x equals 0 and ended at x equals 4. So therefore, that's how you know this is 0 to 4. Okay, so we get pi r squared minus pi small r squared. So you are going to factor the pi, make it easier. So we're going to put the pi outside. So we get big R squared minus small r squared dx. I do this to make it easier to calculate. So now I'm going to get pi 0 to 4 integral, and then we already found that the big R is a function of square root x plus 1. So you're going to get square root x plus 1 whole thing squared, and then minus your small r is going to be half of x plus 1. Okay, so now we got our integral. So next step, we just have to type it into the calculator. So I am going to show you. Okay, this one of the method that we learned before. I am going to make my y1 equal to square root x plus 1 and my y2 equal to 0.5x plus 1. And then later on, all I have to do is going to be integral 0 to 4 y1 squared minus the y2 squared dx. Alright, so integral 0 to 4 y1 squared minus y2 squared dx. This made my life easier. So now my y1 will be square root of x plus 1. And my y2 will be the small r, 0.5x. You can type in the half x. Okay, so now I'm going to go back. So I'm going to do math 9, 0 to 4. Then I'm going to do y1 squared minus y2 squared dx. Okay, so 5.333 something. Okay, so let's see, I can turn it back into a fraction. Nope, okay, because there was square root over there. So now I'm going to get pi. I didn't type in the pi, so therefore you still have the pi times, okay, 5.33333, 1, 2, 3, 4, 5, 6, 7, 5, 4. Okay, and I don't want to leave my answer this way, so I'm going to times pi. So I turn it into pure decimal. So I got 16.75516214. So I finished. So we found the volume that is 16.755. So we finished today's lesson.